Things called turning points. Now, I mean, it kind of is self-explanatory. The point at which a polynomial switches direction. Okay, what's that mean? That means that as you're moving along on a graph, at a certain time, let's say on this one we've got on the screen, I start with my finger here and I start to go and I'm moving up. At a certain point, I stop going up and I start going down, kind of like a roller coaster. You're going up, and then you hit that top point and we go crazy. We go down until we get to a certain point, and then all of a sudden it turns and it starts to go up again. So those turning points actually have names. And so what we're going to call them, and I'm going to, I'm going to use the actual correct term here. If the turning point is higher, if it's at the top of what we're doing, that is called a relative. I'm not so worried about the word relative. I'm more worried about the word maximum, or we can just call it a max for short. So anytime we're at the top with our curves and stuff, we're going to have a relative max. If we're going to go, got it. If our turning point is at the bottom, we have what's called, I'm going to have so many chats when we're done with this, a relative minimum, or we'll just call it a min. Okay, we can shorten things. So what our process today is going to be is figuring out how to find those on the calculator, because most of the time they're not going to be a nice clean whole number. They're going to be some other stuff. So those min and max values are called extrema, which means they're the extreme high and low values. Okay, so again, what's the main thing I want you to remember? Okay, when we're going through these. And we are not going to worry about this whole idea of increasing versus decreasing. Talked with some of the other teachers. We think it's a good idea. We'll save that for the upper level math classes. So, how do we do this turning point thing and find mins and maxes? First thing we do is get that in our graphing calculator. So, move this up a little bit. Again, if you haven't gotten a graphing calculator, you're going to want to, because I'm telling you, it's a lot easier if you know the button presses here. So when we're typing stuff in, reminders again, the X is right here next to alpha, right next to the green button. This little up arrow that you see here that's above the divide is called a caret. That's our exponent button. So we got X to the third. Yes, sir.
What's the word called what? Extreme.
Extrema. Yeah, it's extreme with an A instead of an E. Yes. But when we want to go to our next term, don't just start typing everything. Everything's going to be in your exponent. So if we want to move back down, we got a right arrow. Then we can put the next part in. That is minus 6x squared, not negative. The calculator doesn't like it if you use negative there. Plus 7x plus 2. You've got to make sure that everything, the signs are right, you didn't forget an exponent, all that stuff. So if any of that could possibly get you, we're going to need to fix that. Normally, I would say just hit graph, but my last class has been doing stuff where they're messing with the window all the time. So here's what we're going to do. Zoom up at the top. And number 6, zoom standard will get us back to what we call a normal graph. And you should end up with a graph that looks like this. So I'm going to swing this over for a second. We're going to take a couple notes here. So if your graph ever looks like it's weird or funky or a weird shape, you're like, Hardy, I can't see anything. Zoom 6 is probably going to be your buddy. So once we've got this in here, okay, I notice right away, I see one max up here because it's going up and then it starts to go down. And I see one min down here, okay? When we're trying to figure out what these are, we're going to use the calc menu. So the calc menu is second and trace. Okay, these two buttons, second and trace, gets me the calculate menu. So what we're going to look for here at the start, oh, I already forgotten the picture, which one's which. I'll be back to calculate in a second. Okay, the max is first. Okay. So we're going to go down to number 4, which is the maximum. There'll be times that we do number 3, which is the minimum. But we're doing the max right now. So number 4 is what we want. We're going to hit enter. And this little cursor is going to show up. There he is, right there. You can call him Blinky if you want to. So here's what we're going to do. My first job is to get my cursor only using the left and right buttons. We can't use up or down. Get as close to that maximum as you can. Your blinker should be at the top of the mountain here. Once you're at the top of the mountain, okay, let me get the next step ready to write here. We're going to left arrow, because you see how it says left bound there? That tells you what arrow to use. Left bound, we're going to go 1, 2, 3. So, reminders. Okay, my first job, we used our arrows to get to the min or the max. We did that. Job 2, left arrow 3 times, and then hit enter. If you hit the arrow 3 times and hit enter, 2 things are going to happen. The first thing that's going to happen is, and you can't see it real well because it's close to the axis, there's going to be this really faint line that's there with an arrow pointing that way. Okay? We're setting boundaries right now for our calculator to find this point. So that's going to go in, and your question is going to change. Instead of saying left bound, now it's going to say right bound. So here's what we're going to do once it says right bound. You're never going to guess. We're going to hit the right arrow. And we're going to go 1, 2, 3. That gets me back where I started. Don't hit enter yet. 4, 5, 6. Okay. And hit enter. So let me keep my notes going here. 6 times right and an enter. We're not going to be doing the intervals, so we got room to work with here. So once I hit that enter again, now I've got another arrow. So now I've got arrows pointing both directions, like, hey, hey, right here, look here. This is where the maximum is going to be. Once those are set and the arrows are pointing at each other, not away, at each other, you don't even have to do the guess. When it says guess, just hit enter one more time. And when you hit enter, your little cursor is going to move to the very top of your graph, and the X and the Y values that are at the bottom are your maximum. So for this one, our relative maximum, I'm going to round to the nearest hundredth here. So 0.71 and 4.30 would be my relative maximum. So every one of these graphs that we're going to do, and luckily with the next one, we'll get to start sketching them a bit. We're going to go ahead and we're going to run this exact same process, whether it's a max or a min. The process doesn't change. So let's play again, but we're going to play with the min this time. So, okay, we're already zoomed. We're good. So second trace. Now we're back to our calculate menu. But this time, We're looking for the minimum. We're looking for the bottom that's in the valley. So I hit enter. My little cursor person is back here. So we got to get to the minimum first. So just using, in this case, our right arrow, we're going to get as close to the minimum as we can. It does not have to be perfect. As long as you're close to the bottom, you're good. And then we start the whole arrows thing. So once we're at the bottom, left 3 times, 1, 2, 3, with an enter, because we want to see that faint little line with the arrow. There it is. The question changed. Now it says right bound. So we're going to right arrow. 1, 2, 3, 4, 5, 6. Enter. Much easier to see this time. The 2 arrows are pointing at each other. They're pointing in, saying, hey, the minimum is somewhere between these 2 lines, and we hit enter for the guess. One last time. And our minimum, if we have gotten things okay, let me swing this over here, would be at 3.29 and negative 4.30. This is going to be one of those things that you're just going to have to get used to the button pressing. There's going to be times that you get the directions backwards. It's going to give you an error message. You're going to forget an exponent somewhere. You're going to get an error message. Your graph's going to look weird. It's going to happen. But as long as we keep working at it, we're going to be all right. We're going to get you there. So let's play with another one, kind of see how this goes. We'll go from here. So again, if you haven't gotten hold of a calculator, why not? Would be my question. Why not? Again, when you're typing in your things, make sure that you right arrow to come back down to earth here before you go to the next spot. That in front of x cubed, that's a negative, not minus, so that's the one way down by enter. Again, the calculator's picky about this stuff. So once you think you got it, we'll kind of see if we got the same graph together here. So, all right, so we're going kind of curvy again, but we're going down to the right this time. I'm going to try to increase the size of this a little more. Just a sec here. See if this will help in being able to see things. So I get here. Now you're like, well, wait a minute. If the graph's here, how am I supposed to sketch it? Here's what I tell people to do. If you pull up the table, and we've done that a bunch of times before, second graph, I'm just going to look for points, coordinate points that are going to fit on my graph. Like 54 is not fitting on this graph. 20 is not. Negative 1, 4 can. So 1, 2, 3, 4. 0, 0. All right. 1, 2. 2, 1, 2, 3, 4. Ooh, it's kind of funky. 3, 0. And then we go off to crazy in both directions here. I just want a few points so when I'm graphing, I kind of have an idea. Again, we're not going to get perfection, but we're going to be good enough that we're going to have a pretty good idea that we're in the right area. So the chart will help me out here a bit, kind of see how this works. Then I'm going to go back to doing, oh, can I get it on there? There we go, this stuff. We're already in a normal graph. I don't have to do the zoom thing. So I notice I got a minimum and then a maximum. So I'm going to do the minimum first. So second trace, that gets me my calc menu. We're doing the minimum first this time. You got to tell it the right thing or the calculator don't know what's going on. So you're like, dude, that's like close. Like, I'm just leaving it there. I'm not even going to do the move it. No, I think you're right. So we're already on to step 2. Left arrow 3 times. 1, 2, 3. Enter. There's my boundary line, my boundary arrow. 6 times. Right arrow. It even gives me a hint there to use the right arrow. 1, 2, 3. Back where I started. 4, 5, 6. Enter. Always got to do the enter thing. There's my boundary lines. I don't want to guess. I'm just going to hit enter. It'll do it for me. Okay. Here's the first thing we have to take an extra little note on. Hardy, what's this E thing that's here? Yes. Whenever you see E anything, it automatically means the whole thing is 0. So let's make a little note here. So anytime you see E, that means equals 0. So since I see on both of these, I see E on my X, and I see another E over here, that just means my minimum is at 0, 0. What that actually means when you see the E, it's like scientific notation. So like if it says 1.03 e to the 6, that's actually the number. That's really close to 0. So that's why we just say it's 0. So our minimum, bless you, is at 0. Let's find our max. Let's pull it back here. Same thing rolling again. Second trace. We want the max this time. Left and right arrows only. We're going to get as close to that max as we can. That's pretty good. Then we start the arrow and enter game. Left arrow. 1, 2, 3. Enter. There's my guide. Right arrow. 1, 2, 3. 4, 5, 6. Enter. We're lined up. One last time. Oh, no E's this time. 1.99999. That sounds pretty close to 2 to me. So 2, 4. So we've got our max. We've got our min. Oh, crud, Hardy. You're going to bring us back to all this stuff again. Yep. Yes, I am. Okay. Domain and range. Reminder. Domain is my X values from left to right. But as we've mentioned before, with any graph you're doing in here on these, I don't care if the arrows are going the same way, opposite ways, it makes no difference. Okay? Your domain is always infinities. Always. No exceptions, no what ifs, no but, no, none of that, none of that. But my range, it depends. My range here, when we're looking to go bottom to top, bottom, I see an arrow going down forever in this case. Top, I see an arrow going up forever. Is that always? No. No, it is not. It is in this case, though. And it will be whenever our degree is odd. So, again, we let the picture tell us the story. And then to go back to yesterday. Oh boy, it's end behavior stuff again. Yup. Remember, positive infinity on X goes to the right. Negative infinity on X goes to the left. Your whole job, you have one job and one job only when you are dealing with end behavior. And that's to figure out what's going on with Y. Because this is Y. Y. When you're on the right side of your graph, find the arrow furthest right. Right there. There it is. There's my arrow furthest to the right. Is it going up or down? Down to negative infinity. That's it. That's all you have to do for that part. When X is going to the left, you go to the left side of your graph. You find the arrow. Circle that sucker. It's going up to positive infinity. That's it. That's end behavior. That's all we've got to do with these. We've covered the whole gamut. There's going to be one thing we learn next week. Okay? Other than that, we're covered. So let's play with one more of these. I'm going to hand pick one. Let me look here. I want something that's even. Oh, that's even. Okay, that was down. This is up. Let's just do number 2. That's perfect. Number 2 is going to be spot on for this. Okay. We're not doing intervals. Not doing intervals. Let's do this. All right, clear things out. We'll flip back and forth. So x to the 4th. Arrow to get it back down. Plus x to the 3rd. Arrow to get it back down. Minus 4x squared. We'll keep getting it down here. Plus 5. So once you double check and make sure your signs are good, your exponents are good, your numbers are good, now we're ready to take a peek at this. So let's see what we got here. Oh dear. Okay, that's kind of funky. It's like a squished in McDonald's logo upside down. Sure, why not? So, again, we're only going to use the chart to get us points that fit on the graph. So, -2, -3, -1, 1, 2, 3, 4, 5, 2, 3. Ooh, those get really big then. Okay, so that gets really big, and that gets really big. All right. So coming down to go up, to come down, to go back up. All right, we got the lopsided W. Again, if your graph's not perfect, you're fine. We're just trying to get kind of an idea here. So once we got that, you're like, Hardy, can we do them in order? No, I want the maxes, the mins first. There's a method to the Hardy madness here. So second trace, I noticed, here's my first one. I got a min right here. So let's do a min. All right. Once we've told it what we're looking for, left and right arrows only, in this case left, to get over as close as we can. Then we go left arrow, 1, 2, 3, enter, there's my boundary. Then it changes questions, right bound, right arrow, 1, 2, 3, back where I started, 4, 5, 6, enter, always got to do the enter thing. There's my boundaries, my arrows are pointing at each other, that's what I want to see, bam. So we got -1.84, -3.31. So we got this one. Ooh. Still looks like I got 2 left to do, but I'm going to just go in order. So that looks to be my next one. So I got a max. Same exact stuff except second trace. We want number 4 this time. So you got to tell the calculator what we're looking for. Arrow over. Here, we're coming for you, Max. We're coming for you. Same thing. Left. 1, 2, 3. Enter. Right. 1, 2, 3. 4, 5, 6. Boink. And one guess. Oh, there's that E thing again. Don't get fooled. That's 0. So we got a max at 0, 5. And this time we get a bonus. We have one more. We have one more min to do. Mercy. Second trace. Thank goodness we're not doing like 6th or 7th power stuff. So one more min. So we're down here at the bottom. Left. 1, 2, 3. Enter. Boundary. Right. 2, 3. 5, 6. Enter. Enter. Oh, no e's this time. So 1.09. Oops, scooch over so we can see that. 2.95. Okay. Got all my points. Got my graph. We're going to do end behavior first this time. Now, this end behavior, to me, is really straightforward. Because I look at my arrow on the left and my arrow on the right, and they're both going the same direction. Up, 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 to positive infinity. That part's pretty straightforward. We know what else is straightforward. Domain. I didn't even have to look at the graph. I could have told you what the domain was. Okay. Range is a little funky this time. So here's the deal with range. Because again, we're dealing with y's. Well, Hardy, they're going up forever. Okay, that's cool. We got this side. They don't go down forever. They go down to here. This is the bottom. There is the bottom. You're like, well, what number is that? Well, let's look. That's at a minimum, right? Find the lowest y value on your minimum. That's where your range starts. So if it's not infinity on range, if it's at the bottom, you find the lowest y value in your minimums. If it's at the top, you're going to go looking at your maximum, looking at the y value. That's the only twist. That's the only thing that changes things. So as I give you what I think I would like you to work on, I'm going to give you a couple of heads ups here too. So part number one, I'm just looking at one thing quick. 6 and 8, 6 and 8, 6 and 8. That's what we're going to do. Okay. Day 2, same worksheet we were looking at yesterday here. We're looking this time, though. Hang on a minute. Or is that a better idea? That's an even better idea. Let's just do that. Let's cut another problem off. 6 through 8, 3 problems. I have a couple of warning things, though, that I'm going to say while I'm on this video because I want people to hear it, and I want to say it at the same time. I have a handful of you that literally did not pick up a calculator that entire time. If you don't do that soon, you are going to be hosed like crazy on this quiz. And my opportunity to throw a retake, if you're doing that, is going to be at 0. You've got to put in the work on this stuff. Some of you are too distracted by your phones and all this other crap. I'm not going to have that, and I'm not going to do bailouts this semester. So that's part number 1. Part number 2, you cannot take my calculators out of class. So I'm going to remind you again. If you need a calculator app that will work, that has the same button presses that we did in here, the one for iPhone has changed slightly. I've been told, and I looked myself, Calculate 84 is still an option, but it has like ads and stuff on it now, and if you want to do Zoom and stuff, it's telling you need a premium membership. I'm like, no, I'm not all about that. Calc 84 seems to have taken its place in the free area, and if you have an Android phone of any sort, I have been told so far, at least by my Honors Algebra 2 students, that WabitEmu is still functional. So, WabitEmu. I don't know where they came up with that name, but it works, okay? Those are the main ones that you do. Or if you are dealing with a computer, I call them netbooks. I know people call them Chromebooks. Desmos has different button presses, but if you're on a thing and you can poke where you want to look for the maximum and minimum, you can find it that way. But I'm telling you, when you're in class, take advantage of having calculators and try to do these, because when you're taking a quiz, there will not be Chromebooks out. There will not be phones out. I'm going to make sure of it. So let's start the practice. That's why I'm putting this extra day in. I want to make sure today and tomorrow we've got plenty of time to play with all these buttons and get used to this stuff. So